we're looking at now is we're going to look at a scoping of phase 3, which is at 0.9 volts with no field, and we're looking at its resonant voltage rise, which is fluctuating quite a bit in this instance. Now the scope isn't supposed to change the observation itself, but in this case it may well be true. Now we're going to devote some time to try to fathom some of the idiosyncrasies involved with the oscilloscope and its triggering issues. Now normally I don't think that that resonant voltage rise, it fluctuates as much as it does as we're showing in this video. And there's our background condition again. It's fluctuating all over the place. It doesn't normally do that. Now the reason it might be doing that now is because we've hooked up the scope as a sensoring instrument, and what we've actually been able to do here's the neon. Here's the neon at. Come on, neon. Neon's misbehaving a little bit too. Anyways, we'll go over to our scoping. On this scoping, we got the smaller signal is the source voltage, and the larger signal is the resonant rise of voltage. Notice how the resonant rise of voltage appears to be increasing and decreasing, and also even the source voltage is moving back and forth. And again, the circuit appears to be going in and out of resonance, but now on this it's going in and out of resonance at a much slower rate. Now, this is because of the triggering issue. This is a hard signal to capture actually. Now on the oscilloscope, we got down there on the bottom knob there, A trigger. A trigger has been increased from its normal position about halfway up. Now watch what happens when we slowly move to that triggering issue. We're going to go over there and change that triggering. We're going to decrease the triggering just slightly. Now look what happens. We decreased the triggering slightly, and now we got more pulsation. And I can look right over there on the meters, and the meters themselves are pulsating more. So does this tell us that the oscilloscope is interfering with our own observation? Okay, that's why we can't conclusively say anything about this issue, because of my lack of knowledge of triggering issues. Now, from what I understand, the best approach to take then is not to alter the triggering. We'll put the triggering on both trigger channels back, completely back to normal. Normal on the bottom. Pardon me, cameraman. So now we're seeing that the resonant rise of voltage appears to be happening after the time period of the cause of the voltage. Now let's look. Now that we've done that, let's look at what we can do with altering the other trigger dial. I gotta make room so I can get by here. From 1 millisecond to 25 milliseconds. that level. And when we adjusted that level, it would appear that the voltage across the coil is coming out before the voltage of the source. Now let's go back and adjust the triggering again. Now here's what everybody will say. Well, here's your correct signal, Harvey. It's always supposed to come out afterwards. And so what you're doing here is just a bunch of hocus pocus, and the scope ain't telling you really. You're making the scope read what you want to make it read by your triggering level. So that's why we can't say and use these things as instances of conclusive proof that indeed the magnetic field's coming out before in time, then the cause of voltage and all that lot. So now what we do, we've shown that, that's on channel 3. We're going to try to finish up here and show the scoping on all 3 channels. We're going to put everything back to normal. That's normal there, that's normal there. Now we notice too that the neon, why have I always got the big problem of finding that neon? Maybe I should back out, that would help me out. That's what we need to do. The neon flickering rate is not at all steady in this demo. But we find out that more fluctuation occurs. Let's unhook that neon. That neon causes much more fluctuation to happen. Okay, notice that when we unhooked the neon, that our voltages stopped fluctuating to the great degree that they were before. Now we're going to go back and look at our signals. Here's channel 3. 12.8 volts reference to 0.9 volts going in. We've seen that. We've got to hurry up here. And that looks like an ordinary resonant signal with no triggering issues, except it might appear just a little bit before in time. Now that's channel 3 is the strongest signal at 12.8 volts. Channel 1 is 10.9 volts resonant rise. We're going to go over there and switch it to channel 1. There's channel 1's voltage, and respectively they look in phase. And now we'll go and finish off with channel 2. So phase 2 that is. We're going to change this so we can see the difference. All 3 of these scopings seem to indicate that the system is fairly resonant. But when we've actually done the resonant test, we found out that each of the phases is slightly capacitive. We'll call that quits for this video.